Thank you very much and welcome everybody. And it's a very uh, important session because in the IoT in the new paradigm in manufacturing, we all are aware because of the COVID-19 situation, the whole world is going through a major transformation, or a disruption is the right word. So we all thought that it's time for us to think about Internet of Things, how it will help in reviving the manufacturing. And I have a pleasure and honor of today with my co-panelists, the other speakers. And if you realize that I have somebody from the academia, somebody from the government agencies for standards, somebody from communication industry, and somebody from enterprises who are already implementing the IoT solution industry. So the kind of panel which I have, I'm really feeling that it's an excellent group of people who will be able to share their knowledge, and it will be helpful for everybody here who has come and joined us. I first like to introduce the co-panelists which I have with me today. First is Dr. Brejesh Lal. The proliferation of machines connected to internet and to each other is increasing at a phenomenal speed. According to IoT stats, for 2020, there are 31 billion IoT devices in the world. So Rajesh has been working in the IIT. He's a professor in IIT Delhi, and he has been working on a lot of research. And he will be in a position to tell us more about his research and the work he's doing. We also have Mr. Paventhan, who's a director in ERNET, India, Ministry of Electronics and Information Technology, and he'll be sharing his experience and the work they all are doing.
Sir, can I request you to please check your mic, place it slightly near your face, getting slightly disturbed.
Yeah. So is it better now?
Yes, sir, much better.
Much better.
Yeah. Okay. Thank you. Sorry. So I'll again repeat. We have Dr. Brejesh Lal, who is a professor of IIT Delhi. Dr. A. Paventhan, Director ERNET India, Ministry of Electronics and Information Technology. Mr. Rajiv Desai, IoT Product Management Head in Tata Communication, and Mr. Samip Mutha, Vice President and Head, Digital and Innovation, RPG Enterprises. As I said, we have a academician, we have a standard person, we have a person from communication, and we have a person from enterprises. And I am from Aeris Communication, which is 2-decade-old IoT company. If we think about, just to set the context, the post-COVID time, the 4 M's of manufacturing. The first M is material. The supply chain got disturbed because of too much of dependency on one country. People are thinking about how they can have an alternate location or a near shore location. There is a challenge of machines, the old legacy hardware which are there and running in old factories, how to invest and get them digitalized, or to invest in new thing. The whole board have been thinking about what to do and what not to do. Then the people priority has changed from working and getting more jobs and doing things to how can I save myself and stay healthy. So the people are migrating, so the skill power shortage, and everybody is thinking about how can I have a secure and safe environment. Then the fourth M, which is the methods. So the business processes, the technical processes, the people processes, all needs to change. With these kind of challenge, which have come up because of the new shift in the global environment, and I sometimes feel that unless a human is moved, there is a jerk, there is a push, things doesn't happen. There is a positive or silver lining for that kind of challenge that has happened today in the world, that people have started thinking about what to do next. And all these 4 M's of manufacturing, the material, machine, man, and method, have challenges, but there is a huge opportunity. And for all this opportunity, there are different Internet of Things solutions. There are different standards, there are different ways, there are technologies available now to handle how to take it forward. And this is a time when people have to start thinking about how can they implement different technologies and how can they take these things forward, because they are now available at a price point India needs and the time frame that can be implemented. Before taking, instead of taking much time, now I'll request my panel members to start, coming up, and I'll first request Dr. Brejesh to talk about his thoughts on this particular topic. As I always just want to mention, we have only 45 minutes, and I'll be requesting each and every panelist to take 5 to 7 minutes only to share their information, so that in the end we can have some more knowledge, some questions which we can answer. Dr. Brejesh Lal, request you to please go ahead.
Thank you, Rishi. Thank you, CI, for this opportunity. Morning, everyone. So today we're going to look at IoT, what it means in context of industrialization, industrial manufacturing, and how it is going to bring about a change. Now, before the other learned speakers talk about the change that is happening at this point in time, I will like to talk about something that is going to happen over the next 4, 5, 6 years, which actually tells you that IoT is not here just for today. It is going to stay here for a long time, and it has a role to play in industrialization and industrial manufacturing tomorrow. And IoT is a key player there. So, Kavita, if you could put up that single slide that I had shared, that might help me walk the audience through the ideas that I want to talk of here. Uh, or should I screen myself? Okay, you've received it. Thank you. So now, while they share the screen, let me talk about one thing. To put this talk in perspective, the that I have, just as mechanization was given a huge lease of life by automation, what I'm going to talk about today is the future of IoT. What IoT has done is it has given us the ability to sense and connect. But be taken a step forward, we have to add cognition and comprehension. And once we do that, we will be able to, not just take this level of manufacturing forward, but we'll also be able to take the next step. So continuing with this idea, we have already been able to connect a lot of parts of a factory to each other through sensors. We have been able to connect factories remotely to a cloud server or a central controller, which might be physically displaced from where the factory itself is. What, however, is happening here is that even though, and it's stated here in the slide here, robots, and I quote, are much more consistent than humans and better at precision work, they are inflexible and they are incapable of adaptability and critical thinking. And that is what defines us, the humans. Now, therefore, what is going to happen is the next step is going to be working together so that they can provide assistance to build products which are not just automated, which are not just built with high precision and consistently, but they understand our requirements and they respond to those. Even today, the highest valued products have a huge amount of human intervention in their manufacture. Now, what I'm trying to say here is that in times to follow, a lot more of that will become part of our mechanized, automated, connected sensing ecosystem. So, as we move towards incorporating IoT in our smart manufacturing and moving beyond, what is going to happen is there will be a lot more interworking of humans and machines before machines fully understand what humans want and how they want to achieve it. So essentially, there are two things that I would briefly want to mention today. What we try to do is that IoT now is about sensing and connecting, but it has to move beyond and it has to enable seamless, natural collaboration between humans and machines. And to be able to do this, there are two key technologies which are being focused on these days and will very soon find their way into the market. The first one is the ability for humans and machines to interface with each other, a seamless and natural mechanism for human machine interfacing. The other thing that is going to be important is the ability for the machines to become more intelligent in the sense that they have ability to perceive what the human is trying to say, to comprehend it and put it to practice. Now, looking at these two a little more carefully, when we talk of human-machine interface, what we are seeing is that when humans talk to each other, there are multiple modes of communication. Like, for example, when I'm making this presentation, there are words that I say, but there's also my body language, my facial expressions, and also the way I modulate my voice. All of this is not captured when you have a robotic interaction with a machine today. So what is going to happen is that machines have to imbibe this capability to acquire speech, gesture, understand facial expressions, understand our body language, understand the subtle cues that we send out as we speak, so that they understand what is it that we are trying to say. So this is one aspect of the development. The other half of the development is the ability of the machine to become cognitive, to become intelligent. Now, here it will have to do two things. One is all the information that it acquires while it communicates with humans, what it has to do is try to use it to infer the intention of the human. A lot of things that we do are have got something to do with perception. What we feel is more important than what we read. It's the overall experience is much more than just the sensory inputs that our body gets. Now, the other thing is that not only do they have to comprehend what the human being said, they have to make sense of what the human said, put it in a context of the other sensings that it has done vis-a-vis the environment, uh, apply to it some critical thinking, and come up with a solution that would be beneficial to the human being. So now, what in summary all of this implies is that manufacturing of tomorrow has to move beyond just being precise and consistent. It has to offer a higher degree of user satisfaction. Now, as we move onwards, you might have noticed that even with our communication networks and computing devices, we've started talking of quality of experience rather than quality of service. The same thing will happen vis-a-vis manufacturing. The manufacturing has got to move beyond being precise and consistent. It has to become more amenable, more sensitive to the human requirements, and it has to respond accordingly. And what this means is that the IoT is not only going to be a huge driver in the short term, it is a huge driver in the medium and long term as well. So IoT is something that is here to stay, and it is a huge driver for smart manufacturing. Thank you, Rishi. I hand it over to you with that.
Thank you, Brejesh ji. Thank you very much. It was really pleasure hearing you. I just want to share with the audience that Professor Brejesh Lal ji, who is a professor in IIT Delhi, is also currently head of Bharti School of Telecom Technology and Management and the coordinator of two centers of excellence. They are Airtel IIT Center, IIT Delhi Center of Excellence in Telecommunication, and Ericsson IIT Delhi 5G Center of Excellence. He's also in charge of an IoT laboratory, and he set up in collaboration with Samsung. Beside this, he's the NCC coordinator of IIT Delhi. He completed his PhD in 1997 from IIT Delhi, and he worked with Hughes. So lots of experience. Rajesh ji, thank you very much for your discussion. Now I request Dr. A. Paventhan.
My term as head of Bharti got over a couple of months ago. That is for the audience benefit. Please continue, Rishi.
No problem. The kind of experience you are showing and the kind of work you are doing, Brajesh ji, is fabulous, and it's a lot of learning for all of us. Now I like to call Dr. A. Paventhan. He's the director, ERNET India, Ministry of Electronics and Information Technology. Dr. A. Paventhan is the director R&D with ERNET India, Autonomous Society under the Ministry of Electronics and IT, Government of India, at the IIT Madras Research Park campus. He is with ERNET since 2009, carrying out R&D projects in the domain of IoT, cloud computing, software-defined networking, and visible light communication, VLC Li-Fi. Prior to joining ERNET, he held scientific and research position in the National Informatics Centre, New Delhi, CDAC, Bangalore, and Rutherford Appleton Laboratory, Oxfordshire, UK. He received his MTech computer application from IIT Delhi and PhD in computational engineering from University of Southampton, UK. He's a senior member of IEEE, senior member of ACM, and a member of Internet Society. Such a pleasure to have you, Dr. Paventhan. Looking forward to hear from you.
Thanks, Dr. Rishi, and thanks for Professor Brejesh for setting the tone. So Professor Brejesh mentioned about seamless connectivity of human to devices and to the internet. Probably in this context, I'll try to cover the importance of standards and interoperability in Internet of Things, and also briefly mention about the IoT related initiatives that ERNET is carrying out in this. I think my slide is already shared. Coming back to ERNET, it's an autonomous society within the Ministry of Electronics and IT. As you all know, ERNET has started way back in 1986 as academic project among IISc and IITs. During the period of 1989, Internet has come to India, way back 30 years back, and then connecting ERNET node in Mumbai to the EUNet network in the USA. It is fascinating that now we have moved from simple internet connectivity of human to human communication, having email, telnet, FTP kind of applications, to present day IoT that we are currently talking about, where device to device communication, autonomous connectivity, seamless connectivity to internet. So as we know, traditional industrial control systems have operated mostly in silos. So the standards compliance really an important requirement in IoT solutions, so that various IoT system components can interoperate and seamlessly connect to existing applications that are running on the cloud and the internet. So that is a major advantage when we comply to standards across the protocol stack. So that is the major message that I want to convey. And also the IP layer, the internet protocol layer is actually acting as a glue among the physical and heterogeneous physical and MAC layer. For example, the LoRa and the NB-IoT, Bluetooth, Sigfox, there are so many heterogeneous physical and MAC layer standards. And then we need an adaptation layer like 6LoWPAN or the IPv6 adaptation layer that makes seamlessly the devices to connect to the IP layer and then in turn to the application layer running above it. So the I in the IoT, the internet protocol is a crucial piece in the puzzle. So here we need to enable devices to seamlessly connect to the internet by complying to standards protocols, so that the interoperability and the seamless connectivity Professor Brejesh talked about can be achieved. So some of the agencies like IEEE, IETF, Bluetooth Alliance and the WISAN, LoRa Alliance, so many of them are working in the protocol stack, across the protocol stack, different technologies. So these are some of the standards agency, and also frameworks like Google Thread and Industrial Internet Consortium. There are various standards framework organizations that are defining standards for it. So coming back to, due to paucity of time, let me just quickly go into what ERNET is doing in terms of IoT initiatives. So we have initiated what is known as a 6LoWPAN testbed project way back in 2013, where IPv6 enabled IoT testbeds was deployed at IISc campus and at ERNET locations to demonstrate health and agriculture use case, soil quality monitoring to be specific. And also we extended this IPv6 running on devices and also seamlessly connecting to IPv6 enabled ERNET internet backbone by running various use cases like water quality monitoring, water flow metering, energy metering, enabled through LoRa, and street lighting running based on LoRa network, and also power line communication test bed that we are currently executing at IIT Madras Research Park for a smart building use case. So these are some of the initiatives as a pilot we are carrying out in collaboration with agencies like CPRI, ICAR, and industry partners like Texas Instruments, ST Microelectronics, SLS, Ericsson, and many agencies we collaborate. And also we collaborate with IISc and IIT Madras and many other premier institutions. So ERNET also participate in the ministry-supported initiatives known as Center for Excellence for Internet of Things, which is currently operational in Bangalore, Gurugram, and Ahmedabad, and in Vizag also it's coming up. Many industry leaders like Cisco, Intel, Microsoft, TCS, Wipro, Qualcomm are all partner in this initiative. So the Center of Excellence essentially helps startups and SMEs in developing their IoT ideas into product by providing access to IoT laboratory infrastructure comprising all necessary IoT hardware and software development environment for them to convert their ideas into product. So specific to manufacturing related support, COE also supports co-creation engagement with corporates where industry gives the problem ideas so that startups and SMEs can work on these solutions by working with COE IoT. And also they engage with various industry associations like Industrial Internet Consortium, Auto Component Manufacturer Association in leveraging Industry 4.0 in their own journey. So and also COE organizes various technical leadership sessions in Industry 4.0. So these are some of the activities specific to manufacturing. So with this specific brief, I would like to hand it back to the panel chair. So I would be happy to answer probably once the panel is complete with the initial discussion. Thank you very much for the opportunity.
Thank you, Dr. Paventhan. It was really a pleasure. It was really good hearing from you and your experience in the work you are doing. Honestly, I realized that the time is too short,
Yeah.
and so we need to see how to handle. But I'll definitely like to touch base with you, and alternatively to see how can I learn more. Now I
Thank you.
request Rajiv Desai, the IoT project management head from Tata Communications Limited. Rajiv Desai is a business development and management professional associated with Tata Group since 2002. He has worked in various companies such as Tata Sons, Tata Consultancy Services, Tata Communication, Transformation Services. He has also executed strategic projects with Tata Chemicals, Tata Steels, Wires Division, Rallies, Tata Auto Components, Tata Insights, and Quantas, Voltas, Tata Business. So that's a huge list. Overall, he is a generalist with experience and knowledge across strategic planning and execution, conceptualizing or operationalizing new businesses, business market development, customer and partner relationship management, digital-led business transformations, operations, delivery management. In his current role, he's working in Tata Communication IoT business unit as a business owner for the IoT-enabled human safety product solution and service. Uh, Over to you, Rajiv. Looking forward to hear from you.
Yeah, Rishi, thanks for. So, I mean, thanks for it, and thanks the audience. I hope I'm audible and visible. I mean, there is my internet at my end is a bit patchy. So I would like to build upon what Rishi and Professor Brejesh talked about, the overall man-machine interface in IoT as well. So we have been practicing IoT. I mean, Tata Communications has been the pioneers and the leaders, market leaders in terms of IoT solutions since last 2 to 3 years that we have been into this business. And on the manufacturing side, what we have observed is eventually, from an IoT standpoint, as acting Professor Brejesh also mentioned, is it starts with a niche trying to tackle a man-related productivity issue or a machine-related issue in terms of trying to understand how can we predict a machine maintenance schedule or how can we ensure the machine is working properly, or towards material tracking or any kind of vehicle tracking or any kind of other kind of tracking use cases. That's how the eventual IoT journey actually has begun in the manufacturing. In the post-COVID world, though, this has become more and more important. And the reason I say more and more important is now it has actually become an existential question for a lot of manufacturing units. across all the three elements of a manufacturing or an enterprise setup. For example, for a man or an employee related thing, the questions which are getting asked is how can we ensure safety? How can we ensure social distancing? How can we ensure the employee is still productive in a way that he was pre-COVID and in this current scenario? On the equipment side, material side, it is more about to do that. How can we remotely manage the overall processes? How can we reduce time to service? How can we optimize our overall utilization and all? And this is where we are seeing a huge demand of IoT related solutions and products as we go into the market. And I think Rishi did touch upon one of the key elements that uh, all said and done, look, IoT is all about sensor communication and the overlying application and analytics that sort of comes along with it. And eventually, at the end of the day, while the Western world has actually adopted a lot of IoT use cases, in India, the journey has been a bit slow. Multiple reasons. Obviously, the budget is being one of the critical cases, the cost of the sensors, the overall, the benefits that the companies can get out of it. And in the post-COVID world, this is where we are actually seeing, I would say, tectonic shift in the way people have actually started looking at IoT solutions. For example, I mean, Rishi mentioned that I do head an entire worker safety or a worker health and tracking solution that we have. Uh, During the pre-COVID, it was all about how can we increase productivity. In the post-COVID, the moment we actually introduced some social distancing kind of features in our solution, suddenly we are seeing a lot of enterprises seeing showing a lot of interest and actually trying to do a very quick pilots, trying to get into the mode of deploying some of these things. At the same time, while these niche solutions are seeing an uptake, at the same time, the interfaces, and I think again Professor Brejesh did mention about the interfaces between the man and the machine. This is where we are again seeing a lot of interest picking up, because factories are run at suboptimal levels in terms of limited manpower coming in. The production utilization is actually a bit down, and there how can you remotely manage, how can you ensure that who the person who is managing that particular equipment or managing that particular operation is skilled enough to do that. And that is again where IoT sensors actually are starting building edge analytics on top of it, right? Two sensors talking with each other, trying to exchange information, ensuring that the right person is doing the right job at the right time at the right equipment. So this entire ecosystem of IoT solution is about to see a tectonic shift in the coming few months and quarters, as and when we come out of this overall pandemic for the good. Uh, Also said and done is one thing which is sort of ubiquitous in all the solution that we have, right? Is the communication layer. And I think again we did touch base upon a few communication protocols and layers, but let me tell you, I think in my past 2 years of experience, while that layer is ubiquitous and people think it's a given, that's the most toughest layer to solve, because in your factories your sensors are working in the most strenuous environment. They are working in areas where you have got machines lined up, they are using some other kind of data network and all. And in all that networking or in all that IoT sensors that are there, how can you ensure that the data that a sensor captures is passed on seamlessly? Now that is where the core competency or the core the network part of the data communication also comes into play. What we have observed again is, and I think Brijesh and I think Rishi also talked about 5Gs of the world, the other IoT layer of the world. Like for example, we are working on a technology named as LoRa, which is for long range, low power network. And again, it's more to do with ensuring reach into deep indoors as well. We got Sigfoxes of the world, you got Zigbees of the world, you got Wi-Fi, the good old Wi-Fi. I mean, as part of manufacturing or industry 4.0, Wi-Fi is again become a standard norm. And then on top of it, now we have recently started hearing a lot about NB-IoT. All these technologies have gone through that learning curve. And eventually the element being that whatever technology an enterprise chooses to go with, that technology has to support a lot more ecosystem players, a lot more use cases, and at the end of the day, the eventual TCO that needs to come out of it. This is where at least we believe that the market is moving. And from our perspective as Tata Communications, we do believe that there is a big play on IoT as far as essential services. So we do hear about essential services. There will be a big play on essential services on the manufacturing side. And essential services typically will come under the three buckets of man, machine, material, wherein, how can you optimize operations? How can you ensure that your sourcing channels are seamless? How can you ensure seamless tracking, tracing, productivity, and safety of your employees at the same time? All of this can be bundled and given to an enterprise as a managed services kind of an offering. And this is where we are seeing more and more companies, investing, going for newer use cases, going for newer and innovative ways towards managing the same operations. With that, I would like to, I'm already, I think, 4 minutes into my talk. So with that, Rishi, I would like to give it back to you and maybe open for more questions as and when we end the session.
Yeah, thank you very much, Rajiv. Thank you very much, Rajiv. I think there is some echo happening. So thank you very much for your discussion. I like to request Samip because we have very limited time. Um, Samip is multi-year experience in management consulting, digital transformation, innovation in various industries. He is with me as part of the IET Future Tech panel, and he is one of the key volunteer in the manufacturing one. I am really looking forward to hear from you, Samip. For the time purpose, I request you to please start. Samip?
Yeah, sorry, mute. Can you hear me now?
I can hear you now. Yes, Samip. I can see
Okay,
you and
sure.
hear.
No. Okay. Thank you, Rishi, and thanks CII for giving this opportunity for industry to come and talk about. As Rishi said, I've been basically come from a consulting background for first 12 years, and in a way migrant to digital for last 6 or 7 years that I've been driving digital for RPG Group. So I'm going to quickly touch upon what I have seen in my last 6-7 years as a IoT from a business point of view. See, end of the day, when you go to the business and the CEOs and the CFOs, no, I'm not saying they wouldn't be interested, but they would rather like to see saying that, do you want to do an IoT project? The people would first ask you, say, why? So what I'm trying to bring here, a point here is that the success of IoT and how business looks at it and what kind of a success that we have seen in our journey and some of the possible quick lessons that I'll share quickly. So first of all, if you look at the entire journey of an IoT and the key component, it has device management, integration, data management, analytics, security, multiple things. But for me, and I'm not at all undermining technology, but for me, the most important thing, and I'll pick up the second habit of Stephen Covey, which is begin with the end in mind. Unless that end is very clear, okay, because otherwise the technology and the pace at which it is actually becoming more affordable, accessible, it will do everything and anything that we can ask for. I always say that if you don't know how to do it, it means you've not found the right vendor. Okay, somebody would know how to go about it, provided you are very clear what you want. So I think it is very important in that complete spectrum of IoT, which is on the left-hand side, it can be just one single machine trying to give you some optimization at a local level. In the traditional world, when the worker could not see certain parameters from the machine, the IoT is going to make it more visible, accessible by having an ability to kind of get more and more data. To another extreme, which is right-hand side, where actually IoT becomes the business model. And I'll give example on both sides. So on the one side, you'll have a lot of examples of tracking, tracing, asset monitoring, machine level optimization, as I said, and which we have done in multiple factories, but it happens, as I said, at machine level. And it gives you, of course, certain advantage in terms of lead time, quality, standard manufacturing KPI. On the right-hand side, when you work on the projects like tire as a service, when you work on the project like transformer as a service, and all the projects that I'm speaking are what we are doing or already at the tail end of it, or cables or junction boxes. So the entire smart product space gives you a different advantage vis-a-vis your competition. Now this advantage again has its own pyramid. One could be an extreme new business model, opens up different service line and a revenue line for you, to something which becomes and has already started becoming, because IoT is, in my opinion, is not anymore a new subject, while it keeps evolving. But I think people have gotten their hands tried, tested, understands what. So in the product space also, one is that you have a complete business model or the revenue. To the other end, which is it becomes a hygiene factor. If in the junction box, in the cable, and if you look at all the electronics now, which is coming, already is a smart electronics. So it's almost becoming an hygiene and, as we say, under the parity line parameter for many industries and product. And hence it is important for you to understand and ask the question, when you think of an IoT project, why are you doing it? The data that you will get out of it, how strategically important it is for your business, for your customer. What are you going to do that with data? Is it core? Is it non-core? What I mean by is, for example, a machine improvement is I'm not a machine manufacturer. It is not it's a non-core for me. But if I look at a product as a service or an intelligent tire for one of our, like see it as a factory or a Vacuum or a KEC, multiple companies that Rfid Group has, anything which is core to the business, then your strategy about how do you invest in IoT, whether do it in-house, outsource. So a lot of these parameters becomes important when you start looking at every IoT project, whether it's a core or a non-core. It's extremely important, as I said, because in the world of technology, I think there was a book by Andrew McPhee, which he said actually 4 or 5 years back, he said that anything and everything which costs less than $50 and non-eatable will have a sensor in it. And I think we've reached that stage already. Okay, anything that you can think about, I can put a sensor inside it. But should I do that is a question. Okay, should I put my bandwidth and my effort on that is a question. How much should I spend is a question. And that's where this core non-core is important. The fourth important point is the entire partner and ecosystem that you have, because you might have a smart product, but an ecosystem that you will work with your dealer, distributor, is it going to help you commercialize that product? So it is very important. And there I bring my one more important aspect that I've learned over a period is, for me, the success of IoT is IoT. What I mean by is it's independent of technology. That is a long form for my IoT. IoT does not depend on technology. The success of IoT, technically success, but commercial failure. And I call that syndrome as operation successful, patient dead. So you might have a very technically successful product, but it will fail in the market and commercializing it because no one thought through about the business model change. And hence an entire partner and ecosystem is extremely important as you start your journey on an IoT. And the last important point I would like to bring in, is you have to build the scalability in the IoT. And what I mean the scalability in thinking. How many more people in the organization are thinking of IoT? It can't be one chief digital officer, you hire that guy and say that, boss, it's your, now tell me what can I do. Can't happen. You need to actually, and that's where in RPG, we've launched our own digital academy, which actually the purpose was get more and more people from bottoms up to start thinking of digital IoT in different domains. So we had manufacturing as one domain, supply chain as one domain, digital invoice as one domain, smart products. So we've got 7, 8 areas, and we said from the MD to the operator, everybody goes to the first level of digital academy, which was yellow belt. Then we said green belt, then a black belt. Basically, idea was that it can't be, well, a chief digital officer and his office can be a custodian or a facilitator or a navigator. He or she can't take a group PG ahead unless it brings the scalability in the business. And the scalability is more important from educating and creating awareness. So you need 20, 30, 50, 100 people whose antennas are up in the factory, up in the offices, up in the operations, sales field, when they think of a scenario and they think of new use case. Unless you, so I'll summarize saying that begin with the end in mind, build scalability, core versus non-core, partner and ecosystem, and the last is, for me, the success of IoT is independent of technology. Okay. Without undermining technology, but equally important is look at why am I doing it and how will I actually commercially make it successful. So in the pocket of time, I think I'm trying to kind of encapsulate a lot of thought. There are many examples I can talk about. I'll leave it to the Q&A and as much time what is left with us, Rishi.
Yeah, thank you very much, Samip. You know, today I learned another abbreviation for IoT. I used to say India of tomorrow. Okay. So we have 2 questions and we have 3-4 more minutes left. So one question which has come from Suresh LG. How is RFID being used in IoT? And I'll request if Brejesh ji can take that question.
Okay, yeah. So RFID is one of the many sensing modalities that form part of the IoT system. So in an IoT system, essentially what you're doing is sensing and connecting this sensed information to a central or a distributed processor. And so to repeat, RFID is a cheap sensing mechanism. And not only cheap, it is a simple sensing mechanism. And while answering this question, let me just add one thing. We must be extremely careful at the amount of sensing that we are doing about the capability of our sensors. With so many years of research in the area of computer vision, I say that computer vision is overrated. Just because human beings, 80% of our perception of the environment is because of what we see, does not mean that is how the environment has to be sensed. Computer vision is both in terms of the hardware and in terms of processing. It is an overkill. So, sensors like RFID, which are simple, which are cheap, will form the sensing mechanism of tomorrow. Even sensing computer vision is going to become simpler in times to come.
Thank you very much, Brejesh. There is another question which has come from Sumit Sharma, and that's the last question we are going to take today. He's asking how a mechanical background student can make his future in IoT. I don't, I'll request Dr. Paventhan if he can answer this, if he likes to.
Yeah, probably for this question, probably Professor Brejesh is the right person, but still I would like to add some points in terms of how a mechanical engineer can get into IoT. IoT is essentially an interdisciplinary domain. So definitely there are multiple, so not only for electronic student, so mechanical sensor design, for example, IoT node design, so those are gateway design, and so many mechanical engineering work is involved in IoT, because the end-to-end integration of IoT system requires multiple disciplines of engineering. Definitely, there are mechanical engineering specific domains where IoT, for example, in the manufacturing sector, how let's say tactile internet or any robotics control can be used for manufacturing. Professor also mentioned about RFID. They are used in supply chain and so forth. So definitely, the IoT is about multidisciplinary. Yeah.
And
Thank you,
if I
Dr.
may,
Paventhan.
that's a very good answer, Paventhan.
Please.
I would want to add a little bit here. What you must understand is that there will be two more changes in IoT. Right now, you are assuming that the object or the sensing that is being done is static. A sensor and let it be there. That is not something that is going to happen. Sensor is also going to be deployed on mobile platforms. So you will have automatic guided vehicles. You might have autonomous mobile robots. Now, this is one platform where mechanical engineers have a huge role to play, even without coming out of their domain. Where mechanical engineers have a huge role to play along with materials people is the tactile internet. IoT is going to include haptics as a modality in times to come. And haptics is a lot of mechanics. So what you must understand is that tomorrow's IoT will have a lot more mechanics and mechanical engineers in it, using their or employing their domain knowledge, and they don't have to become peripheral to mechanical and focus on IoT. You can be core mechanical and make significant contribution to IoT in tomorrow. Thank you.
Yeah. Thank you very much to all. It has been really a pleasure. It was a learning session for me too. And I really like to thank all the speakers again for their time and all the people who have participated and here. I hope this was a bit useful. Just I'd like to say that, our time is over. We are available on our LinkedIn and other profile. If you have any question, we all will be more than happy to answer.